Hello, so today we are talking about sampling distributions for proportions. So we've talked about sampling distributions for means. Today we're going to focus on proportions, and this is section 7.2. So we moved forward and did 7.3. Now we're backtracking and doing 7.2. So let's review this slide. We've seen this before, but we're going to focus on if the population proportion is P. So population proportion is P. I use P hat to estimate P, and P hat is the sample proportion. So I use the sample proportion to estimate the population proportion, and this is going to be the theme of today. So just a quick notation review. It says, suppose you have a population in which 80% of the people have registered to vote. Is the value 0.80 a parameter or a statistic? Give the appropriate notation. So the problem gives me 1%, it gives me 80%. Is that 80% talking about 80% of the sample or 80% of the population? Well, it's talking about 80% of the population, so 0.80 is a parameter because it's dealing with the population, so we say P equals 0.80. If it was a sample, we would say P hat, but since it's the population, I just use P. So keep that notation in mind as we talk about our two types of sampling distributions. So we've done the sampling distributions for means, we've done this one, and today we're going to focus on sampling proportions. In sampling proportions, the mean of P hat, so this means the mean of my sampling proportion, or the mean of the sampling distribution for proportions, equals P. Meaning, whatever this true P is, whatever the population parameter is, the average of my sampling distribution is going to equal that number. So whatever this P is, my samples are going to be centered around that P. So what is P hat? Just to review, P hat may be given as percents, counts, or a proportion. So in the problem, it could say 80%, which we saw in the first example. It could give me a count, or say 80 out of the 100. So that would be a count, or it could give me a proportion or a decimal like 0.8. So we could see percents, counts, or proportions. How I find what P hat is it's the number of successes out of the sample size. So we've talked about successes before being X, so it would just be that number of successes out of the sample size, which would be given in the problem. This is an extra YouTube link that talks about sampling proportions and sampling distributions as a whole. If you want to reference this link, it's a great video to watch. So if I talk about sample proportions, they describe the sampling distribution for the proportion of successes in a simple random sample. So if you're writing stuff down, which everyone should be writing stuff down, so when you write stuff down, you need to get this down. So, this right here. So the mean and the standard deviation, you need these formulas. All this is saying is that we have a large population that's centered at P, and P hat is the proportion from the sample. So we just talked about the mean of my sampling distribution is going to be centered at the true P. So whatever this population proportion is, the sampling distribution is centered there. The standard deviation, or the spread, is going to be the square root of P times 1 minus P over N. Well, the standard deviation for my sampling distribution, or the standard deviation of P hat, is going to be narrower or smaller for my sample. So the bigger my sample size, the smaller this number is going to be. Once again, these two formulas are on the AP exam formula sheet, but you do want to memorize them or know what they are because the AP formula sheet has a lot of formulas on it. So let's focus on center. If I want to know what the center of a distribution is going to be, so the center of that curve, I have to meet one condition. So this is key point number 1. We call this the normal condition. I can only use the normal curve, or we use the normal approximation, think z-scores, for a sampling distribution of p hat if the values of n and p meet this criteria. So this is saying my sample size times p is greater than or equal to 10, and the sample size times 1 minus p is greater than or equal to 10. Both have to work. Both must work in order for us to use z-scores. So let's take a look at that example again and kind of build on it. It says, suppose you have a population in which 80% of the people have registered to vote. So we know that P is 0.80. If you take a random sample of 100 people, so sample of 100, N is 100, what would the shape and center be for this distribution? Well, the shape, we said in order for it to be normal, N times P must be greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10 in order for this to be normal. Well, let's check that. If I do 100 times 0.8, 100 times 0.8 gives me 80, and 80 is greater than or equal to 10. So my first criteria checks. It works. Well, let's take a look at the second because they both have to work. 100 times 1 minus 0.8, is that greater than or equal to 10? Well, 20 is greater than or equal to 10, so that condition works. So I can say that my shape is normal because these two criteria are met. So shape is normal. The center of p hat, or mu of p hat, we said just equals p, which is 0.80. So I have my center is at 0.8, and the shape is going to be normal, so it's going to look something like this with 0.8 at the center. So the spread, we have shape and then we have spread. The spread of the distribution is my standard deviation. So key point number 2 is the 10% condition. We had this same condition for means. The 10% condition says that in order to use this formula for standard deviation, the population, or N, has to be at least 10 times larger than the size of the sample, or lowercase n. And we said in symbols, we notate it like this. Capital N is greater than or equal to 10 times lowercase n. So this is the second key point, and let's see how this works in our example. So we have the same population in which 80% of the people have registered to vote, so P is 0.80. We take a random sample of 100, so N is 100. What would the spread for the sample distribution be? So I'm looking for sigma of P hat, but in order for this to be used, I have to make sure that N is greater than or equal to 10 times lowercase n, or my population is at least 10 times the size of my sample. So N has to be greater than or equal to 1,000 people. Does it say that there's more than 1,000 people in the population? No. It doesn't say that, but we can assume that there are more than 1,000 people. Usually we're going to have to assume this condition because it's not going to be given in the problem, but we can assume that there's more than 1,000 people in this big population where people are registering to vote. So since we assumed this and we checked that condition off, now I can find the standard deviation of p hat, which is the square root of p times 1 minus p over n. Well, that would be the square root of 0.8 times 1 minus 0.8 over 100. Well, when I do that in my calculator, I get the square root of 0.0016, and that gives me 0.04. So the standard deviation of p hat is 0.04. I was able to use this formula and get this standard deviation because I assumed that my population was at least 10 times as large as my sample. So, to bring all of this together, we know the shape is normal, the mean of p hat is at 0.80, and we know the standard deviation of p hat is 0.04. Well, when would I want to know this information? I would want to know this information if I want to know a probability. So if I read this problem, we have the same population where 80% have registered to vote. We took the sample of 100, but this is the kicker right here. It says, what is the probability that only 77% of the people in the random sample have registered to vote? So this, what is the probability, should scream in my mind, I need to use a z-score. Z-scores. So z-scores are used when I'm looking for the probability. It tells me that 77% of the people in my sample, so p hat is 0.77, only 77% of the people have registered to vote, and I want to know what's the probability of that happening. Well, if I have a sample, a population, and a standard deviation, I can say that my z equals p hat, or the sample proportion, minus the population proportion over the standard deviation of p hat. So get this formula down. It's the same format as all the other z-scores we've taken. It's the sample of 0.77 minus the population of 0.80 divided by the standard deviation of my of the sampling distribution, which is 0.04. That gives me z equals negative 0.75. Well, if z is negative 0.75, if I draw my little normal curve, 0, 1, 2, 3, negative 1, negative 2, negative 3. Negative 0.75 is right about here. And I want to know what's the probability that this many or fewer. So I'm shading below. Well, if I want to know what's the probability I'm below negative 0.75, when I look at my normal curve, this area is 0.2266, or about 22.66% of the time you will have 77% or fewer people in your sample register to vote. So about 22.66% of the time, you will have 77% of the people or fewer in your sample registered to vote. So why we find the mean, the normal curve criteria, and the standard deviation is so I can find a z-score to find a probability or percent. So that's a wrap. We use sampling distributions of sample proportions to estimate probabilities. We always check the two conditions, the normal condition and the 10% condition, to determine if we can use sampling distributions for proportions. So that's a wrap, and I'll see you next time.